The Tadpole Galaxy, catalogued as UGC 10214, is one of the most visually striking examples of tidal disruption in the observable universe. Located approximately 420 million light-years away in the constellation Draco, this galaxy owes its peculiar form to a cosmic encounter, a gravitational interaction with a smaller, intruding galaxy that passed too close. The result is a sweeping, luminous tail of stars, gas, and star clusters stretching more than 280,000 light-years into intergalactic space, more than twice the diameter of the Milky Way. This tail, composed of tens of thousands of newly formed stars and massive young star clusters, is the signature of tidal forces at work. When two galaxies interact gravitationally, especially in a near collision, the intense tidal forces can strip stars and gas from the primary galaxy, creating elongated streams that trail off into space. These stellar bridges and tails preserve the memory of the interaction, tracing the trajectory of the disturbance and revealing clues about the intruding body. In the Tadpole Galaxy, observations suggest that the smaller galaxy pierced through the larger spiral, triggering shockwaves and redistributing angular momentum across its disk. The gravitational pull pulled gas outward, compressing it into dense knots where bursts of star formation ignited. Hubble Space Telescope images reveal that much of the tail is dotted with brilliant blue clusters, nurseries of massive, short-lived stars that illuminate their surroundings. These clusters are thought to be protoglobular clusters or even the seeds of future dwarf galaxies, forming from material flung far from the galactic core. Unlike symmetrical spiral galaxies, the Tadpole Galaxy now appears lopsided and distorted, its spiral arms heavily perturbed. The galactic core remains relatively intact, glowing with older, redder stars, but the surrounding disk has been reshaped by the gravitational violence. Astronomers estimate that the intruding galaxy, though not currently visible, may have merged entirely or moved far beyond the visible scene, having left behind a trail of gravitational chaos. Tidal tails like the one in UGC 10214 are not permanent structures. Over time, the stars and clusters in the tail may be reabsorbed, dispersed into the halo, or evolve into independent systems. The overall structure of the Tadpole Galaxy may eventually settle into a more regular shape, though it will never look quite the same again. Its dramatic appearance is a snapshot of a brief moment in cosmic time, a fleeting yet grand consequence of galactic evolution. The study of such interactions allows astronomers to understand the dynamics of galaxy formation and transformation. Encounters like this were common in the early universe, when galaxies were smaller and closer together, and they played a crucial role in assembling the large galaxies we see today. The Tadpole Galaxy, then, is not an oddity, it is a living fossil of galactic growth, its tail a luminous scar from a creative act of destruction. What makes the Tadpole Galaxy particularly fascinating is how it embodies the dual nature of cosmic interactions, destruction and creation entwined. The violent gravitational forces that distorted its structure also sparked some of the most prolific star formation seen in such tidal features. In the elongated tail, astronomers have identified massive, compact clusters that may one day evolve into standalone dwarf galaxies. These star-forming regions are not randomly scattered, they follow the contours of the tail, sculpted by the same forces that expelled them. Advanced simulations of galactic interactions have replicated features similar to the tadpole's tail, reinforcing the hypothesis that a direct collision, not just a close flyby, likely triggered the disruption. By adjusting parameters such as the mass ratio, impact angle, and velocity of the intruding galaxy, models can reproduce the elegant curvature of the tail and the asymmetric deformation of the disk. These simulations not only match the observed morphology but also provide insight into the timing of the event. Estimates suggest the interaction occurred about 100 to 200 million years ago, a blink in the cosmic scale, yet enough time for entire generations of stars to be born. Beyond its shape and structure, the Tadpole Galaxy also offers a glimpse into the chemical evolution of galaxies. The tidal tail contains both primordial gas and recycled material from the inner disk, mixed and redistributed by gravitational turbulence. This blending process spreads heavy elements, forged in ancient stars, into regions that might otherwise have remained chemically primitive. As these elements fuel new star formation, the tail becomes a laboratory for studying the recycling of galactic material, a vital component of cosmic ecology. Moreover, the Tadpole Galaxy illustrates the fate that may await many galaxies, including our own. In several billion years, the Milky Way and the Andromeda Galaxy are expected to collide in a similarly titanic interaction. Though the scales and dynamics may differ, the principles remain the same. Tidal forces will stretch and warp their structures, triggering starbursts, forming tails, and eventually leading to a new, merged galaxy. In this sense, the tadpole is a window into our future, a prelude written in starlight. From an observational standpoint, UGC 10214 has been studied across multiple wavelengths, including optical, infrared, and ultraviolet. Each window reveals different facets of the interaction. Infrared observations highlight warm dust and embedded star-forming regions, while ultraviolet imaging tracks the youngest, hottest stars in the tail. Together, these views build a composite image of galactic renewal, layered with history and motion. Even the empty spaces surrounding the tadpole are not devoid of meaning. Embedded in the background are distant galaxies, forming a silent cosmic audience to the spectacle of transformation. Some are spirals, others ellipticals, and many may have undergone similar collisions billions of years earlier. In the vastness of the universe, the tadpole's metamorphosis is part of a grander choreography, a pattern of change woven into the fabric of galactic life. The Tadpole Galaxy also invites deeper questions about the longevity and fate of the star clusters formed within its tail. Many of these clusters are unusually massive, containing tens or even hundreds of thousands of stars. Some exhibit properties consistent with young globular clusters, dense, gravitationally bound systems that could persist for billions of years. If they remain intact, they may drift through intergalactic space or be gravitationally recaptured by the tadpole itself, contributing to its eventual halo population. Their distribution across the tail is not uniform, hinting at localized conditions that favored cluster formation in some regions more than others. Shocks, turbulence, and instabilities in the gas likely played a role, compressing matter to the threshold of collapse. This patchiness reveals the subtle complexities of star formation on galactic scales, not merely a consequence of available material, but of the intricate, evolving dynamics of motion and gravity. Interestingly, some of the star clusters appear to be isolated, with no obvious gas or dust nearby. This raises the possibility that their birth clouds were quickly dispersed, either by stellar winds from massive stars or by supernova explosions within the cluster itself. Such feedback mechanisms not only shape the fate of the clusters but influence the broader environment of the tidal tail, potentially halting or propagating further star formation along its length. The galactic core of UGC 10214, though less visually dramatic than the tail, holds its own story of resilience and restructuring. Despite the external chaos, it remains a coherent and luminous center, surrounded by distorted spiral arms. These arms appear stretched and dislocated, likely due to the transfer of angular momentum during the encounter. The disk, while no longer symmetrical, shows signs of settling, suggesting that the galaxy is in a transitional phase, no longer undisturbed, but not yet stabilized. Over the coming eons, the Tadpole Galaxy may gradually reshape itself. The tail, while prominent now, will likely fade as star formation slows and the stellar population ages. The hot, massive stars will exhaust their fuel and explode as supernovae, leaving behind neutron stars and black holes, while less massive stars will evolve more gently, contributing to the diffuse light of the galactic outskirts. The overall brightness of the tail will dim, leaving only a faint stellar stream as a reminder of its once glorious arc. For astronomers, the Tadpole Galaxy is more than a visual curiosity. It is a dynamic system that captures a pivotal moment in a galactic life cycle, an ongoing transformation recorded in matter and motion. Each observation is a frame in an unwritten film, a record of forces too vast to control but elegant in their consequence. In observing UGC 10214, we are not merely looking into space, we are watching the slow, majestic unfolding of time on a galactic scale. As time progresses, the Tadpole Galaxy may undergo additional encounters or minor mergers, further shaping its destiny. The universe is not static, and galaxies seldom remain isolated forever. If smaller satellite galaxies or intergalactic clouds drift near UGC 10214, they could be drawn in by its gravity, adding fresh fuel for star formation or stirring new waves of disruption. These future interactions may alter the remaining structure of the tidal tail, either reinforcing its form with new material or disrupting it entirely. There is also the intriguing possibility that the tadpole's tidal tail contains enough mass and cohesion to form tidal dwarf galaxies, small, independent systems born not in the early universe, but as a result of galactic recycling. These systems, if they survive, could orbit the tadpole or drift into intergalactic space, becoming relics of the original collision. Observational campaigns using instruments like the James Webb Space Telescope may soon confirm the true nature of some of the denser regions within the tail, whether they are bound systems on the path to independence or simply transient stellar associations. From a cosmological perspective, the Tadpole Galaxy serves as a tangible example of hierarchical structure formation, the process by which large galaxies assemble over time through the merger and accretion of smaller ones. This process, predicted by models of cold dark matter cosmology, plays out not only in the early universe but continues today, albeit at a slower pace. UGC 10214 is a modern witness to the same mechanisms that built the Milky Way, Andromeda, and countless other massive galaxies over billions of years. On a more philosophical note, the Tadpole Galaxy is a reminder that beauty in the cosmos often arises from violence. Its graceful tail, curving delicately across the void, is the result of a gravitational clash that shattered the equilibrium of a spiral disk. The chaos of that interaction gave rise to order, new stars, new clusters, and a structure of haunting symmetry born from disorder. It invites us to see the cosmos not as a place of perfection, but as a realm where impermanence and transformation are the norm. Each galaxy like UGC 10214 that we observe frozen in a moment of transition is a mirror reflecting the evolutionary paths that galaxies walk. Some settle into serene spirals, others into spheroidal ellipsoids, and still others remain misshapen, caught in cycles of interaction and regeneration. The Tadpole Galaxy may one day settle into a more typical spiral or lenticular form, or it may remain a unique monument to a singular cosmic encounter, its tail gradually dispersing like smoke after a celestial storm. Until then, it continues to glide through space, carrying the memory of its past and the seeds of its future. Though distant and unreachable, the Tadpole Galaxy carries a quiet resonance with our own galactic fate. When astronomers look upon its extended tail and twisted spiral arms, they glimpse a possible preview of what will occur when the Milky Way and Andromeda Galaxy collide, an event forecast to begin in about 4 billion years. Much like the tadpole, that collision will not be a cataclysmic smash in the way humans imagine, rather, it will be a prolonged gravitational ballet. Stars will rarely collide directly, but their orbits will be irrevocably altered. Spiral arms will be shredded, tidal tails may unfurl, and gas clouds will compress to ignite waves of starbirth, echoing the same processes at work in UGC 10214. The Tadpole Galaxy, then, is a fossilized moment of cosmic choreography, an unfolding drama captured at its most expressive stage. As its stars continue to orbit, as its clusters age and disperse, the galaxy's structure slowly responds to internal forces trying to restore balance. Differential rotation will gradually smear the tail's features into more diffuse streams. The galaxy's inner disk, though misshapen, may realign its spin axis and settle into a new configuration, albeit forever marked by asymmetry. Residual oscillations in the stellar orbits will take hundreds of millions of years to dampen, fading like ripples on the surface of a disturbed pond. And yet, even as its most dramatic features fade, the history of the tadpole's encounter will remain encoded within its stars. Astronomers can measure the chemical compositions and velocities of individual stars and clusters to reconstruct the sequence of events, much like reading the sediment layers of a terrestrial canyon. These stellar fossils retain imprints of the galactic disk they once inhabited, the gravitational fields they traversed, and the explosive environments in which they were born. In this way, the tadpole continues to tell its story, long after the visual spectacle has dimmed. It also becomes a case study for understanding dark matter, the invisible scaffolding that shapes galactic evolution. The behavior of the tail, the deformation of the disk, and the motion of star clusters all respond not only to visible mass but to the underlying distribution of dark matter within and around UGC 10214. Simulations suggest that dark matter halos extend far beyond the luminous parts of galaxies, and interactions like the tadpoles provide a rare opportunity to test those models. By comparing the observed motion of tidal features with theoretical predictions, astronomers refine their understanding of how dark matter governs cosmic structure. Above all, the Tadpole Galaxy speaks to the profound truth that even the most stable, majestic structures in the cosmos are subject to change. Galaxies are not fixed monuments, but evolving organisms, vast, luminous archives in constant motion. They are shaped by forces beyond their control, yet each bears the unique imprint of its history. In this light, UGC 10214 is more than a galaxy with a tail. It is a memory in motion, a cosmic scar painted with stars, glowing quietly in the dark. In observing the Tadpole Galaxy, we witness not only a moment of disruption but a form of rebirth on a galactic scale. This rebirth is not sudden, nor is it complete, it unfolds across hundreds of millions of years, layer by layer, star by star. The tidal tail, born of violence, becomes a nursery for new light. The old, orderly spiral is broken, but from that fracture emerges something richly complex, perhaps even more dynamic than before. It is a reminder that in the universe, endings are rarely absolute, more often, they are thresholds for transformation. Some astronomers propose that the Tadpole Galaxy is transitioning into a new morphological class. It began as a relatively normal spiral galaxy, but following its interaction, it now defies simple classification. Its asymmetrical disk, extended tidal structures, and profusion of young clusters suggest a hybrid state, an intermediate phase between a spiral and a future lenticular or irregular galaxy. This notion challenges rigid taxonomies and underscores a broader theme in astrophysics, that galaxies are not static objects placed into boxes, but fluid systems in constant evolution, reshaped by their environment and past. Galaxies like the tadpole are also powerful tools for engaging the human imagination. Their forms, distorted yet beautiful, serve as metaphors for resilience, adaptation, and the interplay between chaos and order. The long tail arcing across the cosmos evokes the brushstroke of an artist, or the trailing thought of a memory half-faded. It invites not only scientific inquiry, but philosophical reflection. What does it mean for something so vast to carry the evidence of its past across time and space? What lessons can we draw from a system that finds equilibrium through disorder, and grace through collision? In educational outreach and public science, images of the Tadpole Galaxy have become iconic. Captured in exquisite detail by the Hubble Space Telescope, its sweeping arc and glowing clusters captivate audiences far beyond the scientific community. These images bridge the abstract scales of astronomy with something deeply visual, even emotional, the kind of imagery that invites wonder rather than mere observation. Through the tadpole, people begin to grasp the living nature of galaxies, the slowness of cosmic time, and the poetry of creation through disruption. The galaxy continues its silent journey through space, spinning, transforming, and aging. Though we observe it as it was hundreds of millions of years ago, its evolution goes on. Perhaps, in the distant future, it will find a new symmetry. Perhaps it will acquire new companions, absorb more satellites, or become part of a larger structure within a galactic group. Whatever its path, the Tadpole Galaxy stands as a beacon of motion, of change, and of the profound interconnectedness of matter in the universe. To study it is to listen to the echo of a cosmic encounter, not just through light, but through form, through pattern, through time itself. It reminds us that galaxies are not isolated islands of stars, but part of a vast, unfolding story written across the fabric of spacetime, a story in which even the most distorted shapes hold elegance, and even the most violent collisions give rise to light. The Tadpole Galaxy, with its sweeping stellar tail and disrupted spiral form, is far more than a fleeting curiosity of galactic dynamics. It is a profound expression of the universe's ability to shape order out of collision, light out of rupture, and structure out of motion. Seen through the lens of deep time, the tadpole is not frozen in distortion but caught in the act of transformation. It represents a process that spans hundreds of millions of years, one that began with a gravitational brush of two galaxies, one small, intruding, and now possibly vanished, and continues as the stars, gas, and dark matter of UGC 10214 reshape themselves in a quiet cosmic aftermath. The long, luminous tail that gives the tadpole its name is not merely an aesthetic flourish, it is a direct record of tidal disruption. As the smaller galaxy plunged through or closely past the primary spiral disk, its gravity tugged on the stars and gas, tearing them away along lines of tidal force. These lines formed elegant arcs that curve outward from the galaxy's core, tracing the orbit of the intruder and mapping the direction of the gravitational disturbance. What we see now is not the moment of impact, but the aftermath, a galaxy unraveling, healing, and simultaneously bursting into new life. Within the tail are regions of extraordinary astrophysical activity. Embedded among the diffuse streams of starlight are massive blue clusters, some larger than those found in the disks of many galaxies. These young clusters, only a few million years old, are the glowing signature of triggered star formation. The sudden compression of interstellar gas, caused by gravitational shockwaves and turbulence from the collision, created perfect conditions for the collapse of gas clouds into dense star-forming regions. These bursts of star birth act as cosmic punctuation marks, brilliant, short-lived beacons illuminating the ghost of a violent past. The tadpole's tail stretches over 280,000 light-years, a scale difficult to fully comprehend. It is more than twice the diameter of the Milky Way and contains a mass of stars sufficient to populate small galaxies of its own. It is not homogeneous, it bends, thickens, and tapers, its density fluctuating along its length like a river of stars flowing into the blackness of intergalactic space. At its base, near the distorted spiral disk, star formation is more intense, while farther out, older stars drift in silence, their velocities shaped by the gravitational tug of the central mass and the forgotten remnant of the intruding galaxy. The tail itself may not endure forever. Over time, the gravitational pull of the main galaxy may draw some of the stars and clusters back inward, folding them into the evolving halo. Others may drift too far to return, lost to intergalactic space, forming part of the extended stellar web that threads between galaxies. These wayward clusters, if they remain bound, could become orphan dwarf galaxies, roaming silently through the cosmos, carrying with them the genetic memory of their parent. The central region of the tadpole is no less fascinating. Its bulge remains luminous and relatively compact, likely housing an older population of stars formed long before the tidal event. Yet the surrounding spiral arms have been wrenched into asymmetry, their structure stretched and warped. Simulations of such encounters show that the redistribution of angular momentum can tilt disks, elongate arms, and even trigger internal instabilities that ripple across the galactic plane. The tadpole may be undergoing exactly such a process, its internal motion now out of equilibrium, its stars adjusting to a new gravitational geometry. Even the unseen components of the galaxy, its dark matter halo, are essential to understanding its shape and fate. The halo acts as a stabilizing force, holding the dispersed mass together and dictating how material flows both during and after the collision. Without this invisible scaffolding, the tidal tail might have dissipated more rapidly, or the galaxy itself might have broken apart. Observations of the tadpole structure allow astronomers to constrain the distribution and density of dark matter, turning this disrupted galaxy into a laboratory for one of the universe's greatest mysteries. And in this interplay of forces, there is a narrative that speaks beyond science. The Tadpole Galaxy is, in many ways, a cosmic poem, an epic told not in words but in arcs of stars, waves of gas, and the delicate curvature of a galactic form mid-transformation. It is a monument to impermanence, and a reminder that even at the grandest scales of existence, nothing is fixed. Galaxies are born, evolve, collide, shatter, reform, and continue on, endlessly rewriting themselves. To gaze at the tadpole is to peer into that process, to witness not a static object, but a frame of motion, a still from a film that has no end. It humbles the observer and simultaneously elevates the act of observation. Because within this one galaxy, distorted, glowing, and beautiful, we see a version of every galaxy's fate, and perhaps, in the long arc of time, our own. The Tadpole Galaxy is not merely a distorted spiral, it is a cosmic symphony of motion, gravity, and light, playing out over incomprehensible stretches of time. Its iconic tail is not an ornament but a consequence, a tidal echo cast across the void by a galactic encounter that reshaped its very identity. When we look at UGC 10214, we are witnessing a moment captured mid-transformation, a transitional state between what was and what is becoming. In this moment, form and chaos are intertwined, and the invisible forces that govern the structure of the universe reveal themselves through graceful arcs and radiant clusters of stars. At the heart of the galaxy, the central bulge still burns steadily with the reddish glow of old stars, a population likely billions of years old, predating the collision. These stars move in elliptical orbits, relatively undisturbed, their slow paths echoing a time before disruption. But surrounding them, the galactic disk has been contorted and flung outward, its spiral arms uncoiled by the tidal encounter. One side of the galaxy appears denser and more tightly wound, while the opposite side stretches outward into the tail, betraying the asymmetric gravitational influence of the passing intruder. The structure of the tail itself is an astrophysical wonder. It exhibits not just a linear stream, but curvature and stratification, multiple layers of material from different parts of the original disk. Some regions are rich in gas, others dominated by stars. The most active parts glow with the ultraviolet radiation of massive, short-lived stars that will go supernova within a few million years, enriching their surroundings with heavy elements. These metals will seed the next generation of stars, beginning a feedback cycle of birth and destruction that has operated in galaxies since the dawn of time. Deeper still, the Tadpole Galaxy raises compelling questions about the birth of complexity in the universe. From a system thrown into disorder arises emergent structure, young clusters, spiral filaments, perhaps even dwarf galaxies in the making. This suggests that interactions, even violent ones, may not simply be destructive but are creative in a fundamental sense. They generate diversity in galactic morphology. They trigger processes that might otherwise lie dormant. They redistribute matter and momentum, catalyzing growth in unexpected directions. Astronomers have used advanced simulations to reconstruct the event that created the tadpole. These simulations show that a smaller companion galaxy, perhaps a fraction of the tadpole's mass, passed close to or even through the galactic disk, disturbing its equilibrium. The timing of this event is thought to be relatively recent in cosmic terms, perhaps within the last 100 to 300 million years. In the scale of universal history, this is the blink of an eye. Yet already, the consequences are vast: hundreds of new clusters, thousands of altered stellar trajectories, and a new form for the galaxy itself. The long-term future of the Tadpole Galaxy remains uncertain, but astronomers anticipate several possibilities. Over the next few billion years, the gravitational chaos may settle. The tail could fade into the galactic halo or be stretched thin by rotation and galactic shear. If the companion galaxy was massive enough and remains gravitationally bound, a future merger may occur, fusing the two systems into a new, more massive and possibly elliptical galaxy. Alternatively, the tadpole may stabilize into an irregular or lenticular form, its original spiral identity lost but not forgotten. Yet whatever the future holds, the present moment, the one we are privileged to witness, is uniquely revealing. It allows scientists to study in real time the interplay of forces that drive galactic evolution. It allows us to see how gas dynamics, star formation, angular momentum exchange, and dark matter all coalesce into visible consequences. And it allows humanity, in a rare way, to observe transformation on a truly cosmic scale, not in myth or metaphor, but in starlight. The Tadpole Galaxy also occupies a special place in our cultural and visual vocabulary of space. First imaged in stunning detail by the Hubble Space Telescope in 2002, it quickly captured the imagination of astronomers and the public alike. Its name, simple, almost playful, belies the complexity and majesty of its form. It appears in textbooks, documentaries, and space outreach materials not just because it is beautiful, but because it tells a story of cosmic change in a single frame. Its tail is not just a feature, it is a sentence in the long novel of the universe, one written in gas, gravity, and time. In that sense, the Tadpole Galaxy becomes more than an object of study, it becomes a narrative. One that speaks of encounter and aftermath, of instability and renewal, of the fragile balance between order and entropy. It reminds us that galaxies, like living things, have histories. They are shaped by interactions, by forces outside their control, and by internal rhythms that continue long after disruption ends. And perhaps most profoundly, it shows us that even in the deepest silence of space, there is motion. There is memory. There is change. And somewhere, drifting along the gentle arc of that vast tail, are stars just being born. Their light, still traveling toward us, carries not only energy but information, signals from a moment of creation sparked by a collision long past. In them, the Tadpole Galaxy whispers the quiet truth of the cosmos, that from chaos can rise beauty, from collapse can emerge rebirth, and that even galaxies, titanic and ancient, are still learning to become what they are. Among the many galaxies captured in the eye of human instruments, few embody transformation as vividly as the Tadpole Galaxy. Its appearance is not just a rare aesthetic occurrence, it is a cosmic event unfolding across space and time, a record of a deep galactic encounter etched into its very structure. To contemplate UGC 10214 is to witness an act of gravitational storytelling, one in which the protagonist, a once stable spiral, has been drawn into a chaotic ballet with a smaller companion, and is now emerging from the collision not destroyed, but rewritten. The immense tidal tail that defines the Tadpole Galaxy is a relic of dynamic violence, yet paradoxically elegant in form. Stretching over 280,000 light-years, this arc of light was sculpted not by explosions or fire, but by the silent, invisible hand of gravity. The stars and gas within it did not erupt outward like a supernova, they were gently pulled, strand by strand, from the outer disk of the galaxy as the smaller intruder exerted its influence. The elegance of the tail's curvature reflects the orbital path of this encounter, a galactic scar arcing gracefully across the darkness. And within that arc lies something more profound than displaced matter, there lies creation. In the densest knots of the tidal stream, gravity compressed clouds of gas into stellar nurseries, regions now ablaze with young, hot stars. These stars burn fiercely, blue and short-lived, outshining their surroundings and making the tail shimmer with newborn light. Some of these stellar clusters are vast enough to rival the largest globular clusters found in the Milky Way, others may grow into independent dwarf galaxies. They are fragments of a future born from the unraveling of the past. Observations of the Tadpole Galaxy across the electromagnetic spectrum have allowed astronomers to peel back its layers and read its history. In optical light, the galaxy glows with the scattered brilliance of stars. In ultraviolet, the youngest, hottest stars flare brightly, marking the sites of recent star formation. In the infrared, we see the warm glow of dust heated by these newborn stars, evidence of ongoing transformation. Each wavelength reveals another facet of the event, like a story told in different languages, each illuminating the same truth from a new angle. What makes the tadpole particularly compelling is that it is not unique. Galaxies like it, caught in mid-interaction, reshaping before our eyes, are rare in proximity but were once common in the early universe. During the peak epoch of galaxy formation, collisions and mergers were routine. The tadpole offers a modern echo of that ancient era, allowing astronomers to study in detail what once occurred on a massive scale. In this way, it is both an anomaly and a window, rare in space, but familiar in time. The gravitational interplay that created the tail is also reshaping the internal dynamics of the tadpole itself. The balance between its rotational forces and mass distribution has been altered. The disk's symmetry is broken, its spiral arms stretched and contorted, its structure thrown off kilter. These effects will not resolve quickly. Galactic disks are massive and slow to stabilize. For hundreds of millions of years, waves of motion, ripples, twists, internal warps, will continue to pass through the system as it adjusts to its new state. Yet even amidst this dynamism, the tadpole remains gravitationally bound. It has not disintegrated, nor will it. The galaxy's dark matter halo, vast and invisible, acts like a skeleton holding the system together. It absorbs some of the encounter's energy and buffers the core against complete disassembly. This dark matter framework plays a critical role not only in preserving the galaxy's cohesion but in shaping the final outcome of the interaction, guiding the slow dance of stars, gas, and dust toward eventual equilibrium. There is also an emotional dimension to the Tadpole Galaxy, difficult to ignore. When we look at it, we do not merely see a scientific subject, we see a moment frozen between what was and what will be. It is the visual embodiment of process, of tension between structure and entropy. It speaks to something deeply human, the understanding that even beauty can arise from disturbance, that change is not destruction, and that time is the ultimate sculptor of all things. For earthbound observers, galaxies like the tadpole carry both scientific weight and philosophical resonance. In their vastness and grandeur, they remind us of our smallness, but also of our capacity to understand, to witness, and to be moved. The light from UGC 10214 has traveled over 400 million years to reach us, arriving now as both data and revelation. It is a message from the past, carrying with it not just photons, but patterns, signatures of gravity, history, and cosmic artistry. And yet, perhaps the most humbling truth of all is this: the Tadpole Galaxy is still becoming. It is not finished. It is not fixed. Long after we are gone, long after our civilizations have faded, this galaxy will continue its transformation. Its tail will fade and fold. Its stars will burn out and be replaced. Its form will evolve, slowly, imperceptibly, into something new. It will not remember our gaze. But we, for a fleeting moment, are here to witness its dance, and in doing so, we become part of its story too. The Tadpole Galaxy, though distant and mute across the void, speaks volumes through its form, a form shaped by ancient forces and still evolving today. It is a reminder that the universe is not a gallery of static masterpieces, but a living, breathing continuum of transformation. Each spiral, arc, and filament within UGC 10214 is the visible trace of a gravitational narrative, a story of encounter and aftermath, written not in ink but in light, dust, and time. As we examine the tadpole in greater depth, we find that its iconic tail is not just a visual feature, it is a galactic memory. Every star within it carries information about its origin. Many of these stars were not born in the tail, but torn from the galaxy's disk during the encounter. Their orbits were altered, flung outward along tidal arms shaped by differential gravitational pull. Others were indeed born there, newborns forged in the turbulence of stripped gas that cooled and collapsed under its own weight. Thus, the tail becomes a mixture of the past and present, old stars dislocated from their former paths, and young stars marking new beginnings. This duality, memory and rebirth, pervades the entire structure of the galaxy. The central bulge, relatively undisturbed, is a remnant of its original configuration. It houses older stars that have seen the galaxy through epochs of quiet rotation and internal equilibrium. Around this core, however, the disk has been violently disrupted. Spiral arms, once symmetrical, now flow into elongated streams. Star-forming regions blink like cosmic embers scattered across a shattered canvas. The rotation curve of the galaxy, its internal velocity distribution, has been reshaped, and with it, the fate of countless stars. Even the chemical makeup of the tadpole is changing. The interaction stirred its interstellar medium, mixing enriched gas from the inner disk with more pristine material from the outer regions. Supernovae within the tail will enrich the surrounding medium further, dispersing heavy elements, carbon, oxygen, iron, into space. These elements are the seeds of future planets, the ingredients of life. In this sense, the collision did more than rearrange stars. It may have created the conditions necessary for new planetary systems to emerge in unexpected places, far from the galaxy's traditional nurseries. From a cosmological perspective, what we observe in the Tadpole Galaxy is a miniature version of the grand process of structure formation that has shaped the universe since the Big Bang. In the early cosmos, galaxies were smaller, more irregular, and prone to constant merging. The hierarchical model of galaxy evolution, in which large galaxies are built from the accumulation and assimilation of smaller ones, is vividly illustrated by events like the one that shaped UGC 10214. This galaxy is a snapshot of that process still unfolding in the modern universe, a fossil of formation in real time. But beyond the physics and the data lies something else, a quiet astonishment. That a system spanning hundreds of thousands of light-years, involving billions of stars and trillions of tons of matter, can appear so delicately formed, so almost organic, is a testament to the elegance of the cosmos. The tadpole's tail curves like a living limb, its clusters glow like cellular nodes. It has an anatomy, a rhythm, a temporality, as if it were not just a system of matter, but a kind of being undergoing transformation. And perhaps, in a metaphorical sense, it is. Galaxies, like living organisms, are shaped by their histories. They grow, they collide, they adapt. They bear the marks of past trauma, deformed arms, scattered halos, thickened cores, and they find new configurations in the aftermath. In UGC 10214, we see a galaxy that has been altered not just superficially but structurally. And yet, in that alteration, it has not ended. It has begun anew. Its future remains unwritten. The clusters in its tail may coalesce into satellite galaxies. The tail itself may fade into the darkness, its stars absorbed into the halo or lost to intergalactic space. The core may accrete more matter and reignite with activity, forming a bar or pseudobulge. Or the tadpole may merge again, perhaps with a third galaxy, continuing the spiral of transformation. Whatever happens, the galaxy will carry forward its layered history, each ring of stars, each gas filament, each gravitational echo, speaking of what once was. For us, observers perched on a small planet orbiting a quiet star, the Tadpole Galaxy is a mirror and a window. A mirror, in that it reflects the cosmic processes that once shaped our own Milky Way, which too was formed through mergers and tidal dances. A window, in that it offers a vision of change on scales far beyond our everyday world, a reminder that the universe is vast not just in space, but in time, and that everything within it, from galaxies to civilizations, is part of a larger flow. To look upon the Tadpole Galaxy is to accept that beauty is often born from turbulence, that structure emerges from entropy, and that even in a universe governed by laws as impersonal as gravity and thermodynamics, there is room for grace. The tadpole does not merely endure its collision, it becomes something more because of it. And in that becoming, we find a metaphor for ourselves, and for the universe we are still learning to comprehend. The Tadpole Galaxy, UGC 10214, is not just an astronomical object, it is a living manuscript of the cosmos, a vivid chronicle of celestial transformation unfolding across a stage that spans hundreds of thousands of light-years. Every thread of starlight, every distortion in its one-symmetric spiral, every cluster shimmering in its elongated tail, tells a story of upheaval and recreation. It is a galaxy that has experienced trauma on a galactic scale and is now suspended in the liminal space between destruction and renewal. To study it is to witness time itself in motion, sculpting, twisting, igniting, and rearranging the very fabric of galactic identity. Its name, Tadpole, is deceptively simple, evoking an image of something small, transient, even delicate. But the reality is far grander. The tale that inspires the name is a luminous river of stars and gas over 280,000 light-years in length, trailing behind the galactic core like a cosmic memory unfurling into space. This tale was not part of the original structure. It is the remnant of an encounter, an intergalactic event in which a smaller galaxy, invisible now but once very real, brushed too close to the tadpole's disk. This passing triggered tidal forces so immense that they tore stars and gas away from the outer edges of the spiral, sending them arching outward into space, like sparks flung from a grinding wheel. But what is most extraordinary is that this event did not merely displace matter, it restructured destiny. The gas clouds compressed by the tidal turbulence collapsed into brilliant nurseries of star formation. Dozens, perhaps hundreds, of massive young star clusters were born within this tail, many of them with masses rivaling globular clusters. These clusters blaze blue and white in Hubble's images, packed with hot, short-lived stars that live fast and die young. They represent a fresh beginning, a second generation of light born from the gravitational wound of a close encounter. And these stellar nurseries may not remain tethered to the tadpole. Some of the clusters appear gravitationally self-bound and massive enough to evolve into fully independent dwarf galaxies. If so, we are witnessing the genesis of new galaxies, formed not in isolation like the first galaxies of the early universe, but as recycled fragments of a larger parent. This process, known as tidal dwarf galaxy formation, is rare and fragile, but it demonstrates that the cosmos recycles even its most chaotic episodes into new creations. The Tadpole Galaxy, in this sense, is a cradle of future systems, its tail the nursery of worlds that may one day orbit stars not yet born. Meanwhile, the galactic disk of UGC 10214 is no longer the structure it once was. The arms of the original spiral are now asymmetric and twisted, some more tightly wound, others stretched thin and drawn into filaments. The disk itself is warped not only in shape, but in behavior. The gravitational equilibrium of its stars has been disturbed, with their orbits subtly changed. These distortions propagate through the disk in the form of density waves and oscillations, cosmic aftershocks from the passage of the companion galaxy. For millions of years to come, these ripples will continue, slowly relaxing and reordering the system into a new configuration. At the same time, dark matter continues to play its silent, essential role. Though invisible to our instruments, the galaxy's massive dark matter halo underpins its resilience. It acts as an anchor, stabilizing the core, buffering the mass lost to the tidal tail, and holding the stars in gravitational embrace. Without this unseen structure, the galaxy might not have survived the encounter as a coherent entity. Indeed, interactions like this are among the best natural laboratories for probing the nature of dark matter, because the visible and invisible components respond differently to gravitational disruption. By comparing the motion of stars, gas, and the shape of the tail, astronomers can map the influence of this hidden mass. Beyond the astrophysics, the Tadpole Galaxy resonates with something deeper, a poetic reflection of the cosmos as a place of both drama and dignity. Its form evokes not only scientific curiosity but aesthetic awe. It resembles a comet, a creature in motion, a mythological being, almost anything but a cold, impersonal object. Its form speaks to us on a level beyond calculation, the long tail as a symbol of memory, the luminous clusters as a metaphor for resilience, the warped disk as evidence that even grand structures can be reshaped by forces they cannot resist. Perhaps this is why images of the tadpole have become iconic, because they offer something profoundly human. We recognize in it our own experience of transformation. Just as galaxies grow by collision, so too do civilizations evolve through contact, tension, and synthesis. Just as stars are born in the wake of turbulence, so too do ideas, cultures, and identities arise from moments of disruption. The Tadpole Galaxy is an astronomical object, yes, but it is also a symbol, an illustration of the fundamental truth that from fragmentation, beauty can emerge. And its story is still being written. The clusters in its tail will continue to evolve, burn, and die. The gas will thin. The tidal arm will stretch and slowly fade, its structure dissolving into the galactic halo. The tadpole may merge with other galaxies in the distant future, becoming part of a larger structure, perhaps even a giant elliptical. Or it may stabilize, entering a quiet stage of galactic maturity. Whatever its fate, it carries within it the evidence of everything it has been, a spiral, a collision, a catalyst, a chrysalis. To observe the Tadpole Galaxy is to look at a living page in the chronicle of the cosmos. We are not simply studying it, we are witnessing a form of cosmic becoming. Its shape, though defined by violence, has become a vessel of creation. Its light, having traveled over 400 million years to reach us, brings news not of destruction, but of renewal. In that light, there is meaning. In that tail, there is memory. And in that galaxy, drifting at the edge of our perception, there is the quiet unfolding of time. As the Tadpole Galaxy continues its long journey through the intergalactic void, it becomes not only a testament to past events but a participant in the grander cosmic ecosystem. It does not exist in isolation. Like all galaxies, it is part of the vast web of matter and energy that spans the observable universe, a latticework of filaments, clusters, voids, and dark matter halos that collectively shape the structure of reality on the largest scales. Even now, as its form appears frozen in a moment of tidal chaos, the tadpole is evolving. Gravity never sleeps. The motions of stars within the tail are not random but follow graceful arcs shaped by the central galaxy's mass and the leftover gravitational wake of the encounter. Some clusters will spiral inward, slowly pulled back toward the main body, becoming part of an extended stellar halo. Others will fall into new orbits, populating a vast, diffuse envelope around the core. Still others may reach escape velocity and drift into the darkness between galaxies, lonely travelers born of rupture, fated to wander. This dispersion of stars is a form of galactic memory loss. Over billions of years, the sharply defined tail will fade into a more amorphous halo. The distinctive arc we see today, so iconic and luminous, will become difficult to trace, like an ancient trail overgrown with time. But deep within the stellar populations of the tadpole, the encounter will still be preserved. Astronomers of the far future, equipped with instruments that may surpass our own in precision, will be able to decode these fossil records, the motions of stars, the chemistry of clusters, the metallicity gradients of the halo. They will read in these markers the same story we read now, long after the visual evidence has dissolved. In this way, galaxies become historians of themselves. They carry within them the scars and signatures of every interaction, every burst of star formation, every redistribution of matter. And for us, watching from across the cosmic gulf, they provide a mirror. Our own Milky Way bears similar scars, streams of stars, warped disks, captured dwarf galaxies, and outer halos that betray a long and violent past. The tadpole shows us what such a process looks like while it is still unfolding, with its threads exposed and luminous. But there is another dimension, quieter, more philosophical, that the Tadpole Galaxy reveals, the persistence of beauty in an indifferent universe. It did not set out to be beautiful. Its form is not a design, but a result, a confluence of mass, velocity, trajectory, and time. And yet, what emerges from this confluence is something graceful. Something that, by the human eye and mind, is interpreted as aesthetic, elegant, even tragic. The long tail is not simply a stellar structure, it becomes a gesture. A reaching, a spiral, a remnant of contact. It becomes a symbol of change, not as loss, but as evolution. This is the paradox of cosmic violence. While the forces at play are enormous, capable of tearing disks apart, scattering stars, compressing molecular clouds into blazing clusters, they do not destroy in the way we often imagine. They rearrange. They redistribute. They provoke the birth of new structures. Even black holes, those ultimate destroyers, are now understood to see the formation of stars and regulate the growth of galaxies through feedback and outflows. So too, the Tadpole Galaxy. It has not died. It has not ended. It has transformed. And this transformation is ongoing, visible not just in the structure of the galaxy, but in the way we relate to it. Each new observation adds layers to our understanding, new wavelengths, deeper exposures, spectroscopic surveys, simulations that mimic its formation and predict its future. With each layer, the tadpole becomes more than an image, it becomes a dialogue between the cosmos and consciousness. A point of intersection between the laws of physics and the human search for meaning. This is what makes galaxies more than data points. They are archives of motion and time. They are the places where matter becomes luminous and tells stories. And among them, the Tadpole Galaxy is one of the most eloquent, because it is caught in a rare moment of in-between. Between one identity and another. Between spiral and something new. Between the act of collision and the long settling afterward. Between past and possibility. It is, in every sense, a galaxy becoming. And perhaps, as we continue to gaze outward, deepening our understanding of such cosmic events, we will also begin to see our own world, its cycles, upheavals, and rebirths, as part of that same universal rhythm. The Tadpole Galaxy reminds us that creation is not always quiet. That beauty often comes trailing the light of catastrophe. That even in the cold vacuum of space, there is something tender in the way gravity draws stars into new orbits, lights new fires, and reshapes the old into something luminous and entirely unrepeatable. And so, the Tadpole Galaxy drifts onward, quiet, immense, unfolding. Its shimmering tail stretches behind it like the echo of a forgotten dance, its core glows with the steadfast light of ancient stars, and its scattered clusters pulse with the fire of stellar birth. It is a galaxy no longer what it was, and not yet what it will be, a luminous fragment caught mid-transformation, suspended between memory and possibility. Long after its tail fades and its form settles into new symmetry, the tadpole will remain a cosmic witness, a chapter in the grand narrative of galactic evolution. It reminds us that in a universe ruled by gravity and entropy, where nothing remains untouched by time, even disruption can be a pathway to renewal. That change, far from signaling an end, is often the beginning of something more intricate, more vibrant, more alive. In the stillness of deep space, the Tadpole Galaxy continues to evolve, not alone, not forgotten, but forever traced in the light that reaches us across the ages. It is not simply a collection of stars, it is a portrait of becoming. A celestial symphony still playing its next movement. A vision of what the universe is always doing, transforming, remembering, and shining anew.